right. I think that I'm ready to rock and roll. Cool, let's do this. Okay, so in the last lesson, we spoke about parabolas a lot, and we spoke about standard form of a parabola, which looks, in fancy algebra form, it looks like that. We also spoke about the alternate form of a parabola, which looks a little bit interesting, which looks something like that. And if we had to fill in numbers for these, maybe we would say something like that, or maybe here we would say something like this. Okay, so we have to be familiar with the two different forms, and we also saw that you can break up the one form to turn into the other and vice versa. There were 5 steps that I spent a lot of time teaching around drawing graphs. Can someone come online and remind me, or put it in the chat, what were the 5 steps that we spoke about that helped us draw graphs? So let's go to Fatejo. Fatejo, what can you remember about those 5 steps?
Hello, sir.
Hello.
So the first step was to identify if the parabola is happy or sad.
Okay, and this one, is it happy or is it sad?
It's happy, sir.
It is happy. And the reason it's happy is that the A value, which controls the shape, is positive. So that's important. Okay. Now, what's step 2? You remember that?
Step 2 is finding the y-axis.
The y-intercept. You're close.
The y-intercept, yes.
Okay. And the next one?
Finding the x-intercept.
Okay, and we make y naught. And can you remember 4? I'm really pushing you here, but...
I think it's finding the axis of symmetry. So we use the formula minus b over 2a. Yes.
Yep. Okay, and step 5?
Finding the turning points.
Okay, and how do I get, so I've got my first value from the axis of symmetry. How do I get that y value?
So you substitute it into your equation.
Yes. You have remembered it all. Well done.
Yes, thank you, sir.
Okay, now today we are going to briefly look at another form of the parabola called the root form. And the way the root form works is we write y equals a, and then we go x minus x1 times x minus x2, which looks a bit weird at first, but there's something quite important about x1 and x2. And maybe some of you have seen this in class. So what are x1 and x2 in the root form, of the parabola? So that was the turning point form. That was standard. And who feels like they know what x1 and x2 are? And Paul has said they are the x-intercepts, and so is Kat. Yes, they are. So, for example, if you had a graph that looked something like, say, like that, and let's say this was 3 and this was -1, then 3 would go, say, here, and -1 would go there. And so that is what those values are. And then in order to find the equation of this graph, all you would then need to still work out is to work out what A is. And we'll talk about that later in the lesson. Okay, cool. Give me a thumbs up if you feel like you followed all that. Give me a thumbs down if you feel a bit lost. Okay. Awesome. So what I want to do now is I want to focus on the turning point form of a parabola for a little bit. And in steps 4 and 5 of the drawing a parabola, you find the axis of symmetry and you find the turning point. And basically the axis of symmetry is just the x coordinate of the turning point. And you can use the formula minus b over 2a if it's in standard form. But what happened in the last lesson is I had to break apart this whole I had to break apart this whole thing and then get it into standard form. And then I had to apply the formula. And that took a lot of effort. It's useful to be able to do, but it takes a lot of effort. And there's a quicker way. So I want to show you the quicker way. So if you imagine what transformations are happening in this first graph, I'm going to call this A. If I had x squared, okay, it would look like that. And the turning point would be at 0. Now, I want to ask, well, in the last lesson, I said that this -2 does something and the +1 does something. So who would like to tell me what the -2 does? Who feels like they know what the -2 does? Okay, let's go unmute Kat. Kat, what do you think the -2 does?
Hi, sir.
Hello.
So the -2 is going to shift the graph 2 units to the right.
Yep. It would move that red dot 2 units to the right. What do you think the +1 does?
It would shift the graph a unit up.
You know your stuff. So the new turning point would be there, and the graph would look something like that. Thank you, Kat. That was super helpful. Now, that is enough for us to work out what the turning point is. You can kind of see what the turning point is here. Okay. Now, before I read off the turning point, I just want to ask for bonus points. What does the 3 over here do? What do you think? So if I had to take into account the green kind of takes into account the 2 shifts, what does the 3 do about the graph? It's a bit harder. It's not impossible. I've lost my chat thing for a second for some reason. Where did it go? It gets narrower. It changes the gradient. Yes. So if the A value is bigger than 1, all that's going to happen is it's still going to have the same turning point, but it just goes up steeper like that. Okay, now, what I want to suggest is that if it's in turning point form, if you want to get the turning point, all you need to do is take the number that's next to the x and put a minus in front of it. So you go -2 to get the x coordinate of the turning point. And then you go, what is the y coordinate here? It's going to be 1. And so the turning point of this graph is going to be 2, 1. And you can see that because you moved across by 2 and up by 1. So of course it has to be 2, 1. But that's super useful and super quick for finding the turning point, instead of having to make it into standard form and then going through the whole process. So I want you to find me the turning point for B, C, and D using just these formulas for parabolas. And then you can pop your answer in the chat. What are the turning points for these 4 parabolas? Okay, so the first turning point is -2 and -1. So yeah, you always do, yeah. So what I'm doing is to see where is I'm looking at what is here, and I'm saying the other way of thinking of a turning point, we often say it's -PQ. And so if we look here, we go, the P is +2, so you go -2, and then whatever Q is this bit over here. And so for C, my turning point is going to be 2, 7, because again, I go, it's -2, which ends up being 2, 7. Now, what is my D value going to be? What is my D value going to be? So Issa, I agree with you. It's going to be 2. And Cody agrees. Pema agrees. So we are all good. Okay. Now, why am I showing you this? Because obviously, if you're given a graph in turning point form, it's a bit of a gift. Because instead of having to go a long way to work out steps 4 and 5, you know that for let's say, for example, we are trying to draw, the graph D. Okay. And you're doing your steps. It's happy graph because there's a 1 in front. Step 2, you find the y-intercept. You can make x naught. You can do that. Step 3, find the x-intercept. Steps 4 and 5 are chop because you just say x is 2 for the axis of symmetry, and the turning point is going to be 2 minus 7. So you still have to do this working out. But how much quicker is 4 and 5 when you can just go straight to the turning point? What a glorious gift that is. Okay, so let me now ask you about something called range of a parabola. And so I'm going to use the same graph. So if I was trying to draw graph D, I know that my new turning point is at 2 minus 7. So it's going to be down here, and probably looks something like this. Okay, it's not perfect because I haven't worked out my x and y intercepts, but I know that that is x is 2, and I know that this point is 2 minus 7. Can you find me the range of h? And h is this graph here. What is the range of this graph? And maybe somebody can put their hand up if they know a little bit about ranges. What's the range of D? It looks to me like it's a happy graph, but it only gets so low and it can go no lower. So this is the range I'm asking for here. If I look, the range relates to the y values, and it looks like the lowest value it ever gets to is that. So this graph goes, it can go up. You can feel the arms going up, but it never gets below that value. Okay, so the correct answer for D's range would be y is greater than or equal to minus 7. Or if you use interval notation, it could be, sorry, y must be greater. So then in this case, it could be, it should look like that. And it should include, sorry, I've done it the wrong way around. Those should be like that and like that. So that is the range of D. Are there any questions or comments about that? I think maybe we should do one more here about this type of thing. Can you find me the range of C? So what is the range of the graph C? So the range is relates to the y, which y values are valid? Yes. So for this one, we know the turning point is 2, 7. And we know it's an unhappy graph. So it probably looks something like this. So what's the range of C going to be? So it feels to me like this unhappy graph only gets so high and then it gets no higher. And so we would say y is less than or equal to 7. Yeah, agree level, I agree. Now, some of you may be thinking, why am I only asking you about the range? Well, in a parabola, now in other functions it's different, but in a parabola, every single x value can be put into the formula. So when we talk about the domain of a parabola, the domain of a parabola is x is any real number. And so that's why it's not a very exciting question. So that's why I'm not asking you about it. But, you know, it's good to know any x value can go into this function, which means any x value is defined and will be in the domain. So the greater than or equal to sign is important because if you just said it was greater than, it wouldn't include the turning point. The turning point literally has the value 7. And so you have to say y is less than or it's equal to 7 because the graph does get up to 7. Okay, so I think it's now time. The way you know if it's greater or less than, so think about the shape. This shape never gets greater than that. It never gets higher than this. So it must be less than the highest point. Whereas in the other graph, it never gets lower. So it must be greater than the lowest point. Okay, let's get on to the main part of the lesson. We've done a good bit of revision, and I like what I was seeing in the chat. So for finding the equation of a parabola, I'm going to do an example, and then you're going to mimic the example that I show you. So we have a parabola on the left-hand side here. And the important thing that I notice is the x-intercepts are 1 and 5. So I'm going to write the parabola in root form. And when I write it in root form, I always have x minus something and x minus something. And those somethings are the x-intercepts. So it's going to be a 1 and a 5. However, we still need to find this a value. What do you think I could do to figure out what that a value is? I'd love someone in the class to maybe offer a suggestion as to, using what you know about functions, how could I go and find that a value? Let's go. Can we unmute Ipele? Hi, Ipele. What do you think?
Hello, sir. I think we should substitute any y value.
Okay, you're right. We should substitute any y or a y value, but I'm going to mute these two.
Sir,
Would you? Yeah.
I didn't catch that.
Okay. Would you agree that we've already used 2 points, and so we can only use the point that's left to sub in the
Yes,
minus 12?
which is 12, right?
Yeah.
Yes, sir.
Okay, fantastic. All right, so we are going to put, like Ipeling suggested there, we put 12 equals a. Okay, the a is not changing. And here we put minus 1. And then in the other x place, we put minus 1. So to make this a little bit clearer for you, let me highlight where I put my minus 1s. And let me highlight where I put the 12. So I would like everyone to find me the value of a. What is the value of a going to be in this particular scenario? Okay. So we have 12 equals minus 2 times, oh wait, let me not forget the a. 12 equals a times minus 2 times minus 6. So we get 12 equals 12a, which means a is 1. Okay, so we're quite close to our goal now. All I need to do is replace the a value that I didn't know before, and now it's 1. And so what I'm going to do is I'm going to say y is equal to 1, x minus 1, x minus 5. But that's not standard form, so I need to still multiply out this. And so all I do then is I get x squared minus 5x minus x plus 5. And so the equation of my graph, my parabola, should be that. Okay. Now, I want you guys to see if you can use the process I've just showed you and do it on your own example. So here is another example. And I want you to try and see if you can figure out the equation of this parabola given only the information on the graph. So over to you. Let's see if you can do it. Yeah, Ipileng, what's your question? Can you unmute Ipileng, please? Yes, Ongani, I'll re-explain in a moment now. Yeah.
So do we only use this formula when we have like only 2x intercepts?
Yes, that's very important. So Ipileng's asked a very good question. Depending on the information that you're given, you would use different forms. Now, in the examples I'm currently giving, you have both the x-intercepts and another point. And so this method works for that situation. But there will be another situation, which I'll show in the second half of the lesson. Okay, Ongani's asked me to re-explain. So Ongani, what I do is I start by writing out the format that I know I'm going to have. And in the first one, it's basically that. Then I go look for my x-intercepts. So in the second example, what do you think is going to go in those blank spaces for the second example? Based on what you see there. So we're going to go -1, yes, and then you're going to go -4. But what is sneaky, well, it's that sneaky, but this is going to be +1 and this is going to be -4. Now you have to sub in the point 0, 2 because you've used up these ones and you only have that one left. It's +1 for Tekel because it's minus, and then there was a minus, so 2 minuses make a plus. And this is... So the A value that I get is -2/4 or -1/2. Now we're not done. You still need to get me my final equation. So I want you to take the -1/2. I want you to put it back here, and I want to get me my final equation. But I want to suggest something. Rather multiply the two brackets together first, and then once you've got that, you multiply the -1/2. That's my suggestion. Okay, I see some hands are up. So let's go to Awetu. So Awetu, I'm going to unmute you. What is your question?
Hey, sir, how are you?
Very good. And you?
I'm great. Thanks for asking. So I wanted to ask, you see that part there where it's 2 equals A, open bracket, 0 + 1, close bracket. Yeah. I want to ask, how did we get the 0? Because I'm seeing that we filled in the y-intercept with 2, of course, but I want to ask, the 0 in the coordinates, does it go in both of those two? Is that how we got the 2 zeros?
Yeah.
Or...
Yeah, it does. Okay, good question. So if we look at this point, it's a little bit hidden, the fact that this is the y-intercept, right? But it's in line with where x is 0, and it's in line with where y is 2. So it's a little bit deceptive. So this point, even though it's an intercept, it's still a valid point. So this is an x and this is a y. And so because this says x + 1, the 0 goes here and the 0 goes there. And then for the 12, that must be the 2. So it's kind of like, it is a little bit tricky, but it still counts as a point, even though x is 0. Because now 0 + 1 is 1, and 0 - 4 is -4. Okay. I hope that was a little bit helpful. I know what you're saying. So this is a little bit weird because there's a 0, but 0 is also a number as well. So if I'm going to multiply out now, I should get x² 4x plus x minus 4. Pleasure, Wetu. And then quite a little bit of algebra to do. Now we still need to get that final line. What happened there? We said minus 4x plus x gave me minus 3x. And what is my final answer going to be? I have to multiply all of these things again. So what do I get then? Okay, so a minus a half times 1 gives me minus a half x squared. Then a minus times a minus gives me a plus. So that's 3 over 2x. And then minus times a minus is a plus. That's 4 over 2. That's going to be plus 2. And there you have your lovely parabola. So I just want to come back to that very good question about this method only works when you have both x-intercepts and a point. There is another combination of information which we'll look at after the break. But I just want to point that out, that this is specific to having the right conditions. But from what I can see, we've done well and we've done a lot of work. So I think that we can take a break now so that our brains will keep serving us well. So I want everyone to turn on their cameras and I want you to stand up and I want you to feel human for a second, feel some of the muscles in your body. And we're just going to start with anything that relaxes you. So whatever unwinds you, I like to literally unwind, but you can do whatever floats your boat. Let's roll the shoulders. And then you can roll them back again. And let's do some small circles into big circles. And then let's go the other direction with big circles back into small circles. And then let's just shake out our arms and our legs just to get some blood flow going through us. And let us do some heart rate stuff. So let's do air skipping. So get your virtual skipping rope. And we are going to do, let's do 20 to 25. See how we're feeling. Okay, 3, 2, 1, 2, 3, 5, 6, 7, 10, 11, 15, 16, 17, 20, 21, 22, 24, 25. And have a sip of water if you're lucky enough to have some standing by. Yeah, I hope your brain, I can feel my brain feels better. I hope yours does too. And then who doesn't love a bit of Maths 24? So have a crack at whichever one you think you have the highest likelihood of solving. I don't know where this black bar comes from, but yeah, the way Maths 24 works is you have to use all 4 numbers once and see if you can make 24 using the so which I know there's something about jumping up and down that just you know, like we have bodies, we have to take care of them. And I do try and get my students in class to do that too sometimes. If you just sit too much, it's not ideal. So this is a 9, unfortunately. This is the line is at the bottom, so that's a 9. So I'll give you a tip. If you go 5 minus 1, you get 4. Or actually, no, not 5 minus 1. 5 plus 1 would be a good thing to do. Don't know why my screen is broken all of a sudden, but get rid of that for a second. So 5 plus 1 is 6. And then that means I've used up a 5 and a 1. And then you can say 9 minus 5 is 4. And so we say 6 times 4 is 24. So that is the red one. and I saw a interesting one for Nebocheng. He said 8 plus 5 plus 2 times 2. Now let's see, 13, 16. No, that's too big, unfortunately. Okay, and Paul, you definitely got the red one right. And then, another way of doing, okay, but the problem, Linda, is we're using 6, and unfortunately in the red one has a 9, not a 6. Okay. All right, I think I'm not going to go any further with mastery for today, but if you do come across the answers for the yellow and the blue, feel free to share. But let's get back to our main journey for today. Oh, wait, okay. A yellow, where was I? 8 plus 5 is 13 plus, not quite, unfortunately, but I'll have a go at that maybe later. Okay, now I've showed you how to find the equation of the parabola if you're given a graph like that. Another way of presenting that type of question is instead of giving you a graph, is to give you the actual information. Now, because of time, I'm not going to actually do this one, but I just want to show you kind of how it's a very much the same method. So all you do here is if they tell you the intercepts in that form, you know that it must be x minus 1 times x minus 4, and then that point has to get subbed in to find a. Give me a thumbs up if you understand how the method would still work fine in this scenario. Okay, so I do, because I want to make sure we get the maximum value out of our time together, and so I think most of you will be able to solve that based on what we've done already. So let us go on to a different type of situation. So let's talk about if they give you not 3 points, but they give you 2 points. And one of the points is the turning point. Now, if that is the case, I normally like to think about finding the equation of the parabola using the turning point form. And all I need to figure out is I need to figure out what A is, I need to figure out what P is, and I need to figure out what Q is. But the glorious thing about the turning point is you know that things have happened in this graph. It's been shifted to the left by 3 units, and it's been shifted up by 1 unit. Okay? Now, that allows you to work out what P and Q are. So just because they give you the turning point, you can work out what P is, and it's a little bit harder for P, but for Q, it's straightforward. It's just going to be plus 1. Now, the question about what the X value is, because this is minus 3 is the turning point, this actually has to be plus 3. So you work the other way around when you have a horizontal. And so all you have to do now is find what A is. But you have another point. So there's the other point. So how do you work with it? Well, you put where the y is 5. So 5 equals A. And then for X is 1. And that was there already. Okay, so now 1 plus 3 is 4. And 4 squared is 16. We've got a plus 1. We take it to the other side and we get 4 is 16a. And then if I divide both sides by 16, I get that a is 4 over 16 or 1 over 4. So the equation of my parabola would be a quarter x plus 3 squared plus 1. Okay. Okay, I will slow down, everyone. So don't worry, this is the example that I'm doing. You're going to do an example yourself now. And I'm just going to go through my steps again, because I can see some of you I lost a little bit. Okay, if you look at this point over here, this is the turning point of the graph. And it is minus 3, 1. So if you imagine working backwards, I think all of you will probably see that this 1 has to come from that 1 there. But what's trickier is that there's a -3 here, and that means you have a +3 here. If you understand how I did that, will you give me a thumbs up? And if you don't understand how I did that, give me a thumbs down. Okay, so that's what's causing the difficulty. So just think about it this way. If you look at the turning point, if the turning point has a y coordinate that's 1, that will be Q. But if your turning point has an x value, you need to change its sign to the opposite to get what goes in the thing here. Or you can see that the graph has moved 3 units to the left. And if I move 3 units to the left, I need to have an x plus 3. And if I move up by 1, I have to have a +1 over here. So I'm going to suggest this idea. Let me, instead of worrying about reversing things, this parabola, when it started life as a small little parabola, it had to shift from here to get all the way across. And that's 3 units to the left. And how do we do horizontal shifts? We have to go the opposite way around. So we have to have x plus 3. But then it also had to move upwards by 1. And so that's why we need to have the +1 there. Now, that's step 1. But you still need to sub in 1, 5, which is here's my 1, and here is my 5. And that allows me to know how steep it is or how shallow it is. And so then once I sub it in, I get that A is a quarter. And so we get that. Now, I'm going to go through this with some students now. I can see there are quite a few questions. But while I'm answering those questions, can those who feel comfortable try and find me the parabola in the gray block? Find me the equation of the parabola in the gray block. And let me go to my questions now. Who has a question? Where to? Let's see what your question is. Yeah. Can you hear me? I might have lost a way to there. Maybe some power.
Can you hear me?
Yeah, perfect. Yeah.
Okay, great. I wanted to ask, how do we know when to incorporate this method? So, like, how do we know when to use it? Because previously you said that we have when we have both of the points, that's when we can use the one that we used before. So does this mean we only use this when we don't have all the coordinates?
Okay, very good question. So it's almost like you have to choose the right tool for the right job. But how do you know what tool to use? You have to look at what you're fixing or what you're doing. And so the first thing you do, if you look at, say, this example I've given you, you're not given the x-intercepts. So you know that the tool that goes with the x-intercept isn't going to be suitable. But what you are given is a turning point and another point. And so that tells me in my brain, when I see a turning point and it says find the equation of the graph, I automatically start to think about turning point form. Does that help, Watobe? I don't know. I think maybe you've unmuted now, but I think that would have helped you. So you're right. You need to look in there and see what tool do I use? And then you need to know, you need to have tools in your toolkit. And that's kind of what we're building up today. Ipeleng, let's go to you. What's your question?
Can you hear me, sir?
Yeah.
The first example, Mister, where you said y is equal to 5, right?
Yeah.
So you use that 5 from the other point, not the point of the turning point.
Yeah. So I used the turning point to help me with the first stuff, and then I had to use what was left to help me with the rest.
So that Q turns into the one of the turning point automatically.
So, yeah, exactly. Yes. So let's do this one together. What do you think is going to be at the end here in the second example, based on this?
6.
Yeah, hit it out the park. Now, x is a bit trickier, but I mean, this had to go up by 6. It had to go across by 1 and up by 6. What do you think that in the x in this little bracket here is going to be?
+1.
Yes, well done. You got it. Because it has to be the other way around. Okay, now I want you to, now I'm going to ask everyone to try and find what A is. Okay. Thank you for your question, it's a good one. Okay, we mute, so thanks, great. Okay, now we have to find what A is. And, oh yeah, there we go. So you see there, okay, Pooty thinks, okay, let's have a look. Okay, I think what's a bit tricky is there's a point hiding over here, and that point is the point 0, 3. So, yeah, so if 0, 3 is there, I think that I have to put a 3 where the y is, and I have to put a 0 where the x is. But I also have to deal with the 6. So can you find me my A? Yeah, can we unmute Kat? I see Kat has a question.
So after you found the equation in turning point form,
Yes.
to get it into standard form, we have to expand the bracket.
Yes. Now here's the thing. If they say find the equation of the graph and they don't say leave it in standard form, the turning point form is also a valid form of the graph. It's only if they say that they want it in standard form, or if you want it in standard form because it's easier for you. But I will expand this for you now when we finish, just to show you kind of how it works. So don't worry, I'll give an example for you just so you can see. So this should be A is -3. So the final equation of the graph is going to be -3 x plus 1 squared plus 6. Now, it was asked by Kat, what if you want to change this into standard form? And it takes a bit of effort, and it's not, but you can do it. All you need to do is multiply this out. And what I always say to students is deal with this part first. So I'm just going to do it for you because there might be some situations where you have to do this, but it's not, I don't think it'll be that much because and then what have we got left here? It's just a lot of repetitive algebra, I guess. So the graph up here, this is in turning point form. And in some ways, turning point form, when you get used to it, looks easier. But notice how the A value is still the same. But then the rest of it is written in the form like where A, B, and C is there. Okay. So I hope that was helpful just in thing. Okay, here's another made-up question by me. What is the range of the graph over here? So we have this graph. I want to know, what is the range of this graph? Yes, Vatejo, you've got it. You've got it. So if you look at the highest point it gets to is 6, it never goes above that. So y is less than or equal to 6 would be the range of this graph. And I see lots of students, Ongani, Kapotso, everyone have got it. So that's fantastic. Okay, well, let's do one more like this, and then I'll even squeeze in a little bit of bonus stuff because you guys are flying today. So find me the turning point that goes through 1, 1 and 0, 2. So find me the turning point that goes through 1, 1 and 0, 2. So notice now how you're not going to use the root form. You're going to use the turning point form because they've told you this is the turning point. So find me the equation of that parabola. And Paul has asked, can I write it like that? So if y was it less than or equal to 6? So in that case, y, how did this look? So you've got your 6, it's got to be less than 6, but including it. And then on this side, it would be negative infinity, but you can't include infinity. So that would be another way of writing it like that. And you could write, yes, y is an element of. But you have to go, generally speaking, you're expected to go from the smaller number to the bigger number, Paul. So you shouldn't have your minus infinity on the other side. No, it should be, yeah, the bigger number, 6 is bigger than minus infinity. So pleasure. So, we have to sub in the 0 and the 2. So the 0 is x, so it goes here. And the 2 is y, and it goes here. Then let's think, minus 1 squared is still 1, so I get a plus 1. But if you take the 1 to the other side, it becomes negative. So we get 2 minus 1 is a, and a is 1. So the equation of my parabola is just going to be x minus 1 squared plus 1. Because the a is like kind of invisible in front, right? But you don't write that 1. Okay. Now, you don't have to put it into standard form. You could, but it would just take more work. And why do more work if you don't have to? Give me a thumbs up if you're feeling like you're following everything. Give me a thumbs down if you feel a bit unsure of this last bit. Just want a quick little check-in. Okay, fantastic. Now, you've done so well today. I feel like you deserve a little bit of write it in standard form. Okay, Busisiwe, if I wanted to write it in standard form, I would just want to multiply these two brackets out. And I get x times x is x squared minus x, then another minus x, and then a plus 1. But I also have another plus 1 that was already there. And so we should get x squared minus 2x plus 2. So remember, like this 1 was already here. Okay. So I want to close today with a question about intersection points. Now, I know you're like, oh my goodness, why are you throwing this in now? But I just feel like this kind of goes together. So say that you have, this is our last question of the day, I promise. You have two graphs, and I can see this is a straight line graph, and it's a negative straight line graph, so it's going to look something like this. And this is an unhappy parabola, so it's going to look something like that. I want to find these two intersection points where F and G meet. Can you help me find those now for the last question of the day? And maybe someone can give us a tip if they feel like they've done this sort of question. How do I find intersection points? Don't worry, Linda. By the end of this lesson, you'll be good to go. What is special about intersection points? I think their y values and their x values are the same. Let's go to Tato. Tato, what tip could you give us? Tato, what do you think we should do?
Afternoon, sir.
Hello.
Firstly, sir, we can start by solving the y-intercept and also the x-intercept.
Okay, but
That is
that's drawing the graph here. Remember, you're right. If I was drawing the graph, I would find the
Yes, sir.
x-intercept. But what do I do if I want to find the intersection points? Like these two ones here.
intersection points, sir. You're gonna do the negative b over 2, then finding the turning points. Then you're gonna say that these both of the fx and the gx equal, then you're gonna equal to then find those intersections.
No, exactly. So you take the f and that's the same as y equals y equals minus 3x minus 4. And this is also y. And so all you need to do is you make them equal to each other. And now you solve that equation. So I want everyone, sometimes you can just sub the one into the other. Sometimes you can equate them. But at intersection points, the y values and the x values are equal. So you can solve for x using that. So I want you guys to solve that quadratic for me. Find me my x values that work. And we all know that quadratic equations start by getting it into standard form. So can you get it into standard form? Obile, yes, it is a simultaneous equation. That's exactly what it is. So you could either put the 0 on that side, or I could move all of these guys to this side. Who knows? You be the judge and see what answer you get. I'm gonna move it. And even if your equation looks different, we'll still get the same answer. So, okay, so now we can use either the quadratic formula or we can use factorizing. But either way, you should be able to get me answers. And then pop those answers in the chat when you've got your x values. It looks to me like it probably is a formula question, if at all. What do we get? So 5. You have to get good at using the formula. It's like one of those important skills that you just have to practice until. So b squared minus 4 times 1 minus 1 minus 4ac, and then over 2 times 1. So what are we getting for my x values? So we have 5.19 or negative 0.19. So what I think is happening is that this is the negative 0.19, and over here is the place where it's 5.19. But you still need to find me some y values. So what are the y values that go with those x values? And I think you can figure them out using the original equation, f of x, because that seems nice and simple. So what is going to be my y value and what is going to be my, so what is, y value? It's going to go with this. And then we are done. We've done a lot today. I pushed you, but it's because I've seen how much you're improving, and that's how you kind of get even better. So y equals minus 3 times So it feels like minus 19.57 is the y value that goes with the x value there. And then what about the other one when I have minus 0.19? Notice how I'm using that structure. So we get minus 3.43. And this is what we call our intersection points. So when I'm finding the intersection point, do we equal each equation for any type of graph? Yes, Linda, you do. It's just that sometimes what they do is with the intersection point question, sometimes they say to you like x plus y equals 2 and y equals 2x squared plus 3x. And in that case, you first have to work with the one equation a little bit first. So like you make it 2 minus x, and then you can sub it into the other one. So sometimes you just have to do a bit of algebra on the equations. But yes, if you want to find intersection points, you just make the two graphs equal to each other. So for Tejo, subbing in to the other one is kind of the same as equating. It just depends on the situation. Okay. The question has been asked, how do we get the y values? We take the x values that we found, so like 5.19, and we put them into the simplest of the two equations. So I put that one in there, and if I put x as 5.19, I get out that. And if I put this into the equation, then I would get out that one over there. Alrighty.